Hello students, welcome back. So in this session, I'm going to be talking about list. So list is an ordered mutable collection of elements. Ordered means that the elements of the list, they are printed in the order in which they were entered. This is not true for dictionary and set, and I'll show you in a minute why and how. List can also contain duplicates, and they are also heterogeneous, meaning they can contain elements of like which are integer, string, boolean. They can contain all these types of elements. And what do you mean by mutable? I'll show you through an example in a minute. Mutable basically means something that can be changed. So elements of the list can be modified, they can be changed. So how do you declare a list? The way you declare a list is by using the square bracket. So let me copy this, come over here and run it. All right, so my age is a list. It contains 10, 20, 30, 40, 50, 20, 30. As you can see, it has some duplicate elements. Let's see, let's run this. All right, so I print my age, it prints out my list, and as you can see, it prints the list in square bracket. Just be aware of that. List is always defined in square bracket. And then I print the type. I want to see what type that is, and it tells you it's a type list. All right. What type of elements are in a list? Well, let's start with the empty list. All right, let me comment these lines out. All right, let's start with the first one. So let's say I define my L equal to an empty list, and I print this. It's gonna print nothing. There's a name, nothing in it, right? That's my empty list. Let's populate this list. In this case, I wrote three things: pineapple, banana, and cucumber. So in this case, list contains elements that are all strings. This is a string, this is a string, this is a string. Now if I print L, it's gonna print apple, banana, cucumber. All right. I can have a list where all elements are booleans. You see, true, true, false. If I print this, it's going to print true, true, false. So my list can contain string, it can contain all booleans, or I can have a list that contains integer, integer, and a float, and a string right there. So this list contains integers, float, and a string. If I run this, it's going to print every single element, no problem. All right. Now in this case, I have a list. It contains integer, float, and look at that. It contains another list inside the list. So you can have a list inside of a list. So this is a list, and look, there is another list over there inside a list. And this particular list contains integer, integer, and integer. So if I run this, it's going to print that list. Integer, you see this list contains an integer, contains a float, contains a list, and contains another list. By the way, the length of this list is 3. 1, 2, 3. The length of this list is 3 because there are 3 elements. The length of this list is 4 because there are 4 elements. And the length of this list is 1, 2, 3, 4. It is 4 because it contains 4 elements. 1, 3.2, and then this element right there, this whole list is an element, and then this right here, this whole element. So that's why it contains 4 elements. And then, of course, you can have a really fancy list. I just create this list. So in this case, it consists of an integer, a string. In this case, I'm using single quote, and complex number, and a boolean. And then I'm putting another list inside this. And then I'm putting a list, another list inside that list. And inside that list, I'm putting another list over there. So I can have a list inside of a list inside of a list. And if I run this, it will print out the list. All right. Numbers. So just like you were able to access elements of a string, you can also access elements of your list. And the indexing, just like in a string, also starts with 0. So index starts with 0. If I type print numbers 0, so that means print me element at index 0. This is index 0, index 1, index 2, index 3, index 4. Index always starts with 0 in list, in sequences, in containers. For most of the programming language, that is true. So in Python, indexing starts with 0. So if I say numbers square bracket 0, and if I run this, it's gonna print 10. All right, let me comment these lines out and let me run this again, and it prints 10. All right, If I type numbers 1, it's going to print index element at index 1, which is right here. This is my index 0, this is my index 1, this is my index 2. Run this and it's going to print 30 because this is the number that's present at index 1. What if I say numbers at index 3? I run this and it's going to print 70. So this is my 0, 1, 2, 3. This one is at index 3, it prints out 70. And if I say numbers index -1, if you recall, your -1 is always the end position. If I run this, it's going to print 50 because that is the last index. This one is called -1. This is -2, -3. So you can go backward and you can go this way. If you go this way, it's going to be plus. If you go this way, it's going to be minus. Slicing. All right, let's take the same list. Come over here. And there you go. All right. If I say numbers 1 colon 3, that means slice from index 1 all the way to index 3, but stop at index 3. Do not print out index 3. So it's going to do 1, 2, and index 3. It's going to stop it over there, and it's not going to print 70. It's only going to print 30 and 60. If I run this, it prints 30 and 60. All right. If I type numbers colon 3, that means start from the beginning and go up to index 3. All right, so print out 10, 30, 60. If I run this, it's going to print 10, 30, 60. So 0, 1, 2, and 3. It's not going to print the third one. Okay, that's index 3. Sorry, index 3 is not going to print index 3. It's going to print index 0, 1, and 2. In this case, I'm saying start from index 2 and print all the way up to end. So if I run this, it's going to print from 60, 70, and all the way up to end. 60, 70, up to end. 2 is this index right there. 0, 1, 2. All right. In this case, I'm saying start from the beginning all the way up to end and step size 2. So if I run this, it's going to print 10, 60, 50. Start from the beginning. So remember, the step size is 2. So 1, 2. It's going to print 10 and 60. 10 and 60. Then it's going to go 1, 2. It's going to print 50. And it prints 50 right there. And then, of course, you can reverse a list. And you can reverse a list by typing this little this syntax. So you're saying square bracket colon colon -1. So -1 basically saying step size -1, meaning step size go in this direction. Okay, so it's going to print, if I run this, it's going to print 50, 70, 60, 30, 10. 50, 70, 60, 30, 10. Just prints this basically reverses the list. That's all it does. List modification. Let's create some cells. So let's say you have a list, numbers, and you want to append, you want to add something to the end. The word is not adding, the word actually in a programming language is called append. So if you have a container and you want to put some more elements at the end, the word is append. So let's say you want to append 17 over there. So what's going to happen is going to take 10, 20, 30, 40, 50, and when you invoke this method append to this list, when you invoke this method, it's going to append 17 at the end. So let me comment this out. And let's run this, and there you go. So numbers after append is 10, 20, 30, 40, 50, and then 17 is appended at the end. That's what this thing does. All right. Now same thing, you have numbers 10, 20, 30, 40, 50, and maybe you want to insert based on an index. So now you're specifying that you're saying that, hey, insert element number 25 at index 3. So insert at index 3 element 25. So in this case, this is index 0, index 1, index 2, and index 3. It's going to put 25 over there. So once it puts 25 over there, it's going to move 40 and 50 in this direction. It's going to move them towards right hand side. So if I run this, There you go. So it printed 10, 20, 30, and then it wrote 25 over there, and then 40 and 50 are shifted towards right hand side. So it shifts 40 and 50 over here. It does not overwrite that, it shifts them towards your right hand side. You may want to remove an element. So let's do that. So let's say you have numbers 10, 20, 30, 40, 50, and you want to remove an element based on the value. So in this case, you can just type remove numbers.remove 50. It's going to find 50 and it's going to remove that. So if I run this, let me comment these lines out. All right, let me run this, and you can see 50 is gone. Okay, there was a 50 over here. That 50 is gone because I removed it. All right. You can remove an element based on its index too. In this case, I removed an element based on the value. Now I'm removing an element based on the index. So the index I'm removing is 2. So the command is dot pop. I'm sorry, the method is dot pop. You say numbers dot pop and you specify your index number. So my index in this case is 2. It's going to pop the element at 2. So the element at index 2. This is 0, this is 1, this is 2. It's going to pop this one out. So if I run this, you can see 30 is gone, okay, because this is my element at index 2. Now remember I was telling you list is mutable? Well, there you go. Now, this is not true, by the way, for string. A list, on the other hand, is mutable. So if I have numbers like this, and if I want to change an element at index 2, which is this right here, 0, 1, 2, if I want to change this element to, let's say, 25, this is the way to do it. You say numbers 2, so you access that element and you assign 25 to that element. So now if I run this, it changed it. You see 10, 20, and 25 right there. So this 30 is gone and 25 is been replaced by 25. And 40 and 50, 40 and 50 there. It did not shift 30 on this direction. It actually overwrite. It removed 30 and it put 25 over there. So there is something called append and extend method. So let's say you have a fruits, apple and banana, and you have another fruits, new. Let's call this thing a fruits new. You have another list, and let's say this is cherry and date. All right, so you have two lists, fruits and fruits new. And inside this fruits, you append fruits new. So you take this list and you appending this to this. And then you print your fruits. And then you print also the length of the fruits. So let's see what it does. Now when you're doing appending, what it does, it takes this element, apple, apple, banana, banana, and then it appends this list. Okay, so it's appending the whole list right there. It's not appending the elements of the list. It is not appending the element. It is appending the whole list. And as you can see, it appended a whole list. So if you count the number of elements over here, it is 3. 1, 2, and this thing is one single element right here. Okay, so that's why when you did length of the fruits, it gave you 3. On the other hand, maybe that's not what you wanted. You want to actually put apple, banana, cherry, date in one giant list. So this way you will have 4 elements over there. How do you do that? You use something called extend. All right. So let's say same thing. You have fruits, apple and banana. Your fruits new is, let's say, cherry and date. And the command you use, the method you use is extend. Over here use append. I'm using extend. Fruits new, same thing. And then I print my fruits and I print my length of my fruits. Basically same command, except I'm just replacing append with extend. And if I run this, you can see now it has produced the desired effect. Apple, banana, cherry, and date. So now if I count my elements, it's going to be 4. 1, 2, 3, 4. In this case, there were 3: string, string, and a list. Okay. Sometime you may want to sort a list. Actually, not sometime, but a lot of times you would have to do that. So let's say you have numbers -6, 10, 20, 30, 25, 40, 17. You want to sort that. So you can sort that. List has a method called dot sort, or sort. And by using sort, you can actually sort the numbers. So in this case, when you sort this, it's going to print -6, 10, 17, 20, 25, 30, 40. So this method actually sorts it. You want to reverse a list. So let's say this is your list, -6, 10, all these elements, and you want to reverse it. So the way to do it is just type reverse right there. Just say use the method for the list. Use the list method called reverse, and that's going to take this list and reverse it. And if you run this, it's going to reverse that. All right. So 17, 40, 25, 30, 17, 40, 25, 30, and so on and so forth. Now comes list concatenation and string and list repetition. Very handy tool. So let's say you have numbers 10, 20, 30, 40, 50, and you have some more numbers 77, 88, and 11. And you want to combine, okay, you want to basically take this list and combine them, all the elements together, and create a new numbers. So what you do, you say new numbers equal to numbers plus more numbers. So I'm using plus operator over here, and what plus is going to do is going to take all the elements of this list, it's going to take all the elements of this list, and it's going to combine all the elements together. If I run this, you can see 10, 20, 30, 40, 50, and it combines the other one too. So this is my old list, and this one is my new list right here. You see that? It's a new list. This is similar to extend. If you recall, we were doing something similar. You had two lists, right? Where is that? Yeah, there it is. Extend. You had two lists. This is my first list. This is my second list, and I wrote fruits.extend, and what it did actually took this fruits and it put the fruits new inside that. In this case, I created new numbers, and I'm taking these two lists and I'm combining them and I'm putting it over there. The difference between this and the other one, extend, is that extend is taking the old list, okay, the old list, and it's adding these elements into it. In this case, I'm not taking an old list, I'm actually creating a new list. I'm creating a new list that is combination of numbers and more numbers. Then you can also have list repetition. So let's say I have my numbers, right, which is this one right here, and for some reason I want to multiply by 2. And one application of this, let's say you want to create a data, okay. So let's say you want to create a data and you only have limited amount of data, 10, 20, 30, 40, 50. So if I multiply by 2, if I multiply my list by 2, it's gonna take that list and it's gonna combine, it's gonna concatenate that list to itself. So this way I can increase the length of my data. Now if I can just do maybe 5, it's gonna, my list is gonna become really big. And this way you can actually make a really big list. If you want to test your program, you want to create a data, you can use this this little tool to create a really long list. You can type 100, 200, 1000. Just remember, do not try to print 1000 because it's going to take all of your screen space. Sometimes you want to check if an element is part of the list, if the element is inside the list. You can do that too. So in this case, let's say my numbers equal to 10, 20, 30, 40, 50. And I want to check if 401 is inside my numbers. So in this case, it's going to print false because this number is not there. On the other hand, 40 in numbers, is 40 is inside this list? Well, let's find out. And the answer is true. So this is a pretty handy tool. It's an in operator. Sometimes you have to find an index of an element. So let's say you have numbers 10, 20, 30, 40, 50, and you want to find the index of the number 30. You want to find where exactly your number 30 is located. So you can do that using the method called index. So numbers.index 30, that's going to tell you the index of 30. In this case, 0, 1, 2. The index of 30 is 2. It's going to print 2 right there. Sometimes you want to count how many elements of a certain kind or of a certain value are in there. So let's say my list is numbers 10, 20, 60, 30, 60, 40, 60. And I want to count how many 60s are there. Okay, count all the occurrences of 60. So the method you use is dot count. And if I run this, it's going to give me a count 3 because there are 3 60s. 1, 2, and 3. 3 60s. Sometimes you have to create a copy of a list. So you can also create a copy. Let's just create some more. All right, create a copy of a list. So there are two ways you can create a copy. You can say, let's say numbers is your list right there. You can say n equal to numbers dot copy, and it's going to print your n. So this will be one style. Okay, if I run this, and it prints out your copy. The difference between this and this is that you can actually change the elements of this. You can modify, you can append, you can remove. Nothing will happen to this number. This number will stay intact because this one is a copy of this. So you think of that n as something that you know how you do copy and paste on your computer. So exactly that's what it is. Think of this as a copy and paste. So this is your copy, and you can do whatever you want with the n, and you don't have to worry about it's gonna mess up your old data. Your old data would be remain intact. It would not be harmed. You can also make a copy using this little command. You say numbers colon and then a colon inside the square bracket. So if you run this, it's also going to create a copy. Same thing. So I print n would give me this, and this next print n would give me this. As you can see, they both are exactly same. But this one is a copy of numbers, by the way. Okay, sometimes you may want to create a list. So you can create a list using range function. So let's say you want to create a list of numbers from, let's say, 1 to 12. Well, one way to do this thing is you would have to actually say L equal to, just sit over there and say L equal to, and open the square bracket and say 1, comma 2, comma 3, comma 4, and all the way up to 13. Okay, this is one way. So I wonder if there's an easy way. Okay, so this is not good way. Okay, it will do it, but not a good way, not very efficient. So there is a function called range, and what range does, it generates the numbers for you from 1 to whatever you specify. So let's say I want to generate the numbers from 1 to 13. So basically it's going to generate from all the way 1 all the way to 12. It would not go up to 13. Actually it stops at 13, just like indexing. It will, just like in slicing, it stops at that last index. Same thing, it's going to stop at 13. So it's going to print 1 all the way to 12. So if I run this, it's going to print from 1 all the way to 12. So this is my range. Maybe you want to skip some numbers. Okay, so you want to skip some numbers. So in this case I'm saying 2, 13, 3. So I'm saying start with number 2. Okay, go all the way to 13. Okay, but do not print 13. And then go, step size is 3. So see, it starts with 2. Okay, and then it goes, let's see, it starts with 2, then it goes 1, 2, 3, prints out 5, 5, then it goes again, skips 3, 1, 2, 3 steps, 8, prints out 8, then it goes 1, 2, 3, prints out 11 and 11. So that's what this 3 means. 3 is a step size, like how many step size it should go front. So this way you can print some pretty fancy list over here. Now there are some built-in functions on list. So these are the built-in functions on list. Let's say you want to print a minimum of a list. You can use the function called min. You want to print the maximum. Let me run this. You want to print the minimum. It's 10. 10 is the minimum. You want to print the maximum. Use the max function on numbers. It's going to print 70. 70 is your max right there. Now what about the sum? Sum is going to take every single element, add them all together, and that's going to print 220 because you take all the elements, add them together. That's your sum. Len. Len is the short for length. It's going to print the total number of elements over here. In this case is 1, 2, 3, 4, 5, 6. 6 elements. So it's going to print 6. So length print 6. Sorted. What it's going to do is going to sort this number list in a way. In this case, as you can see, it sorted the list 10, 20, 30, 40, 50, 70. Now, a simple application. Once you have done that, maybe you want to calculate the average. Now, if you remember, what is the average of a list? Well, average is basically sum, right? So I did sum, and you divide it by the total number of elements. And how do you determine the total number of elements? From here, length of numbers. So I divided by the total number of elements, which is length of numbers. So this is my average. If I run this, it's going to give me 36.66. So this is my average. Now comes nested list. Now let's create some more list right there. Let's say you have a matrix. In this case, you can see this is a list of a list. So if I run this, it's gonna print a list, and this list has actually three elements: element one, element two, and element three. I can actually use this feature to actually create matrices. So this actually, I'm just creating a matrix with a list of a list. I can simulate a matrix by using list inside a list. That's what I'm doing over here. All right. Let's say we try to access an element of a list, of a matrix, or of a nested list. Another name for that is a nested list, because I'm creating a list inside a list. That's why it's called nested. So let's say this is a list, calling a matrix. This list contains this list, this list, and this list. So if I print just matrix, okay, if I print matrix, it's gonna print this list right here. All right. What if I type What if I print matrix 0? That's going to print my element at index 0, which is this right here. I run this, it's going to print 1, 2, 3, because this is my element at index 0. What if I print my element at index 1? Well, this one is an element at index 1. If I run this, it's going to print 4, 5, 6, 4, 5, 6, this list. And likewise, if I do element at index 2, it's going to print 7, 8, 9, which is at index 2, which is right here. Now, I want to print an element, okay, at index 1, and inside the index 1, I want to print an element at index 2. So in this case, matrix 1 square bracket index at element 2, which would be this one right here. So 1, 2, 3, which would be this right here. So in this case, index 2 would be 0, 1, 2. So it's going to be 6. This would be 6. So it should print 6. Let's see if it prints 6. Look at that 6. Again, this prints matrix 1, which is my matrix 1 right here. Inside matrix 1, go to index 2. Okay, so this is my index 2 right here. So just look at it and it will make sense. All right. In this case, I'm printing my matrix 2, okay, which is right here. And inside this matrix 2, which is right here, sorry, this one, give me index 1. So in this case, your index 1 is 8, right here, 8, 0, 1, 2. If I run this, it's going to print 8. All right, so this is you'll see occasionally you'll see this type of notation, and that's what's happening over here. Sometime you have to modify a list. You can do that too. In this case, you're modifying the matrix or a nested list. So this is your element, matrix equal to this. Now, if I print the element, okay, my matrix 0, 1. In this case, this will be your matrix 0, right? Matrix 0, and then index element 1. Index element 1 would be 2. So if I print this, it prints 2 right there, okay? Let me just put this thing on the top right there, maybe more appropriate, and then put one more over here. Okay, so I print my matrix. Let's run it again. So first it prints my matrix. I print my matrix. Then I'm printing my matrix 0, 1, meaning print the element at 0, which is right there, and inside this, find me an element at index 1, which is 2, and it printed 2 right there. All right, now I'm changing. I'm saying this particular element, okay, change the value to 99. All right, okay, I change it now 99, and then I print my matrix again, and let's see what it does. And look at that, it changed, and now it printed 99. So you see, before it printed 2, now it's printing 99. So if I comment this line out, okay, I'm just removing the print statement, and if I run this, you see that. So I printed my original matrix, which is right here. Then I changed that element, one of the element, which is 0, 1, which is this one, and then I print this matrix. When I printed, it printed 99 over there. It replaced that. Okay. All right. Thank you, gentlemen.